All right, here is a problem from the first tutorial that some students asked me to record a video about, right? So the problem is probably a little bit confusing because usually you do not work with functions that are defined like this, and it's probably something that you are not very comfortable with at first, right? So let me explain how you could approach these kind of problems. Now, I've been asked to do just part two of this problem, so I'm going to explain part two, right? So here, f is a function defined um, in a piecewise manner, like this, and we need to find a limit of this function when x and y approach, well, in subpart A of part 2, 0, 2, and in subpart B of part 2 to 0, 0. Right? So the first thing that we need to do here is to somehow um, figure out what this function really is, what its graph looks like, or I mean, to get some feeling of the function, right? So how can we do that? So let me just explain what this really means. This uh, piecewise formula here is sort of a recipe how to calculate the function's value, right? So if you want to compute, say, f of, I don't know, 32 and negative 3. So what do you do? Right? So according to the recipe, you should check whether y is bigger than or equal than x squared plus 1. Right? So here y is negative 3. So negative 3 and x squared plus 1. So is it true that negative 3 is bigger than or equal than 32 square plus 1? And the answer is no, right? So no, it's not bigger. So which means that we are not in this case. Now, is it true that y is bigger than, less than or equal to 0? So negative 3 is less than or equal to 0. And the answer is yes. So which means that the value of this function at a given point is negative 1, right? So this is negative 1. And basically, just like that, you can compute the value of the function at any point, right? So here it's negative 1. If you want to compute f of 0, 0, then it's also going to be negative 1 because it satisfies the second condition. So f, say, of, I don't know, negative 3 and 32. So here, x is negative 3. So negative 3 squared is 9, plus 1 is 10. It's still less than 32. So we are in the first case, and it's going to be 3. Right, so, and f, say, of, I don't know, let me say, let's say 1, 1. So here, the first condition is not satisfied because 1 is not bigger than or equal than 1 plus 1. Second condition is not satisfied, so we are in the third condition, and the value here is 0. Okay, so it gives you some idea how to, what the function looks like, and you can sort of even plot it schematically, right? So let me do it. So let me do it like this. So this is the plane x, y, and I'm going to use some colors to show the value of the function, right? So let me pick some color. So along the line y equals x squared plus 1, and above that line, well, it's a curved line, so it's a parabola. Along this line, the value of the function is 3. Right? So here is 3. So along the line y equals 0, and the line y equals 0 is the x-axis, So along the line y equals 0, and below that line, so for negative values of y, the value of our function is -1, right? So let me do it like this probably. So let me erase this, and let me use a different color, right? So along this line and below this line, the value of my function is uh, 0, sorry, -1. And in between these two regions, the value of my function is 3. Right, so it's like this. So here it is 3. No, sorry, it's not 3, it's negative. It's 0, it's 0. It doesn't make sense, sorry. Is 0. Yeah, okay. All right, now we need to find the limit as xy approaches 0, 2, and to find the limit as xy approaches 0, 0. So first, what happens if x and y approach 0, 2, right? So this is the point 0, 2. But you see, near that point, for values of x and y close to that point, the value of the function is always 3, right? So which means that if you pick any particular path, right? So imagine like any path that kind of approaches this point. Along this path near the point, the value of my function is going to be always 3, regardless of the path. So, and the limit along any path here, it's still going to be 3 because the function is just constant, right? So the limit of my function is x and y approach 0, 2 along any path is going to be 3, right? So which means that the limit here is going to be 3. But compare it to the point, to the other point. So, and the other point is 0, 0. So here, if you take any path that approaches this point from below, it's going to be -1, right? So for example, if you approach this point from below along the path x equals 0 and y is negative. So here f of xy is going to be -1, so the limit is -1. Compare it to taking the path from above. So if you take a path from above, so here you approach this point along the path x equals 0 and y is positive. So, and then the value of the function remains, again, along this path remains constant, and that constant is now 0. All right, so here the limit is 0. Okay, so in part B, the limit of my function is x tends to 0, x is 0, and y approaches 0 from below, y is negative. It's going to be -1, but the limit of f of xy when x is 0 and y approaches 0 from above is 0. Since they are not equal, it means that the limits along different paths are not equal, so the limit does not exist. All right, I hope it clarifies.